A couple of years ago, when I visited Japan for the first time, I got to experience the amazing Japanese culture. But something else left an even deeper impression on me. It was the land itself. The entire country felt like it was being squeezed by giant hands from both sides, pushing it up in the middle. That's because Japan sits right along the edge of two tectonic plates, the Philippine Sea Plate and the Amurian Plate, which are colliding with each other at a speed of about 8 centimeters per year. Over millions of years, this has built the Japanese islands, but it also creates a lot of earthquakes. So scientists have been closely monitoring the situation there. But while they've been watching these familiar fault lines, something strange has been happening in the middle of the Atlantic Ocean. No one noticed until recently, but the seafloor around the Azores Islands has been rising up, creating a new mountain range. And this mountain building event has led to some big changes in how we think about earthquakes. There's so much more going on beneath the surface of our planet than we knew before. And it could mean that a massive earthquake is coming. What? Why? How? Keep watching to find out. The Earth's outer layer isn't just one solid piece. It's made of several dozen huge slabs of rock called tectonic plates that are moving all the time. You can think of them kind of like rafts floating on a river. They're constantly bumping into each other, and most of the time they just push against each other and maybe get stuck. But sometimes one plate will slide under another in a process called subduction. When that happens, it's like sticking a puzzle piece under another one. As the plate sinks down into the Earth, it drags the rest of the plate with it, and this pulls the rest of the Earth's crust along. That's what happened to the Japanese islands. The overriding plate is pushing the Philippine Sea Plate underneath it toward the east. That's what makes Japan so seismically active. Most of the time the seafloor just bends without breaking, but sometimes it breaks, and that releases a lot of energy all at once in the form of an earthquake. What's happening in the Atlantic Ocean is the opposite of that. The seafloor is actually bulging upward, and scientists have known about it since the 1960s. Back then, they were studying how magnetic fields were oriented in different places on the seafloor. Magnetic north and south aren't the same as geographic north and south. They change over time. So scientists use magnetic stripes on the ocean floor as a way of figuring out how old the seafloor is and how fast it's moving. Now, as they were mapping out the seafloor, they noticed that the magnetic stripes in the middle of the Atlantic Ocean weren't lined up the way they expected. All the stripes seemed to be originating from a line that ran up the middle of the ocean. This suggested that the seafloor wasn't just sliding apart as it had been created, it was actually piling up. That's because new seafloor was forming at the mid-Atlantic Ridge, a mid-oceanic mountain range that runs down the center of the Atlantic Ocean. Hot magma from the Earth's mantle bubbles up through the ocean floor here and creates vast new expanses of seafloor. So it looks like the seafloor is actually spreading away from the ridge on either side. But now we know that's not what's really happening. The seafloor is actually rising up in the middle and spreading out in both directions. That's part of why scientists were so surprised by what happened in 2021 when they took a closer look at a particular section of the mid-ocean ridge that runs through the Azores Islands. Scientists had mapped this part of the seafloor before, and they knew that it was bulging upward. But they thought it was just bulging upward. But when they analyzed satellite data from the previous decade, they found that the seafloor had risen by almost 4 centimeters, almost an inch, in just 10 years. Not only that, but the uplift had started suddenly around 2010 and was still continuing. And they aren't the only ones seeing this happen. In 2021, scientists reported similar findings from other parts of the Atlantic Ocean too. The seafloor near the Charlie Gibbs fracture zone in the North Atlantic had risen by about 2 centimeters between 2014 and 2018. And the rise began suddenly after a period of quiescence, meaning it didn't happen gradually. It was an almost imperceptible lurch that no one noticed at the time, like the frog in boiling water. It's hard to say exactly what caused this sudden uplift, because scientists didn't see it coming. It may have something to do with the fact that the plates carrying the Americas and Europe are slowly drifting apart. That creates space for magma to well up in the middle and bulge the seafloor upward. But whatever the cause, scientists were surprised to find that the seafloor didn't just move upward, but moved sideways as well. At the same time, the entire region was sliding to the northwest at about 2 centimeters per year. But the uplift that began in 2010 had moved the seafloor about 30 centimeters to the northeast. That may not sound like much, but it was 10 times faster than the normal rate of movement for that area. Scientists don't fully understand why this is happening, but they have a few ideas. The seafloor could be slumping down a bit where it meets the continental crust, sort of like a landslide. Or there could be even more activity happening deep underground that we don't know about yet. For example, there might be a pool of hot magma beneath the seafloor that's slowly squeezing its way up. Whatever's happening, scientists are pretty sure it's related to the fact that this area sits on top of a weak zone in the Earth's mantle. It's called a low-velocity zone, and it's literally what it sounds like. Seismic waves move slower through it than they do through the surrounding areas, and it seems to be made of partially molten rock. That means that the seafloor above it is basically sitting on a layer of hot, gooey rock, and if the seafloor moves in one direction and the layer underneath it moves in another direction, the seafloor could end up sliding sideways relative to the rest of the plate. So scientists used computer models to try to figure out how this might work. Their models assumed that the seafloor was sliding to the northwest, but the layer beneath it was moving to the southeast. They found that under certain conditions, that would cause the seafloor to bulge up and spread out to the northeast. They published their results in 2023, and it looks like they were right. According to their models, the seafloor should buckle upward at about the same rate that it moves to the northwest, and the seafloor near the Azores Islands has been doing exactly that. Now, normally this wouldn't be such a big deal. Uplift like this happens all the time along mid-ocean ridges, and it doesn't usually cause earthquakes. But this seafloor isn't behaving like typical seafloor. The seafloor is mostly made of igneous rock, which is created when magma cools. And igneous rocks tend to be pretty uniform. The minerals and crystals in them are all about the same size, so it's hard for them to get stuck on each other, and that makes it unlikely that they'll cause earthquakes. But the seafloor in this region is unusually weak. It's full of tiny cracks and gaps, and it looks like that's making the seafloor more prone to earthquakes. So while this kind of seafloor bulging is normal along mid-ocean ridges, it's not normal for this particular seafloor, and scientists aren't sure how long it will keep up this behavior. We already know that this seafloor is capable of producing large earthquakes. In 1998, a magnitude 7.2 earthquake struck just off the coast of the Azores Islands, and scientists think it was probably triggered by the seafloor bulging up. If it happens again, it could be even more powerful. In the worst-case scenario, the seafloor could start slipping in the opposite direction, and that could trigger a megathrust earthquake. These are the biggest earthquakes on the planet, and they happen when an entire plate slips past another plate all at once. The largest recorded earthquake in history was a magnitude 9.6 megathrust earthquake that hit Chile in 1960, and the one that hit Japan in 2011 was a magnitude 9.0. So if something like that were to happen along the Azores Islands, it could be catastrophic. But it's important to remember that we haven't seen any signs that the seafloor is starting to slip the other way. And the seafloor does seem to be following the pattern that the computer models predicted. So it may be a slow-moving thing that gives us plenty of time to prepare for an earthquake. Even so, scientists want to keep studying it to find out what's really going on beneath the seafloor. One day they hope to map the low-velocity zone beneath the seafloor and figure out exactly how deep it goes and how big it is. Then they'll be able to better predict the risk of future earthquakes. I love stories like this because they show that the Earth is always changing. We think of the Earth as this solid thing that's just kind of always there, but it's actually full of dynamic processes that are constantly reshaping it. And even though we've been studying the Earth for thousands of years, we're still discovering new things all the time. We've only been exploring the ocean floor since the 1960s, and we still have so much to learn. Who knows what other surprises the Earth has in store for us? Thanks for watching this episode. I hope you learned something interesting. If you did, Please subscribe and leave a comment below to let me know what you think. And if you want to support my work, you can check out the links in the description.